Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to another episode of the Blue Security Podcast. I'm Andy, your host.
I'm Adam, your co-host.
This week, we're going to talk about network security, and we're going to go over it from a high level. We're not going to dive into specific details on rules and all of that, but we're just going to break it down for the basics for folks who may not understand what you need to look for network security and where to begin. And traditionally, this has actually not been a major issue because many security engineers and analysts have come from the network track, but that over the last few years has actually changed. Many of the newer folks are coming from endpoint or from identity, which is not security. And so, or not network security, I should say. And so that skill set is a little bit lacking now. So if that's you, this may be a good episode to kind of listen to and understand. When it comes to networks, traditionally, there has usually been one egress point or IP address block that a corporation or an organization will have, and all your intranet traffic, the internal network traffic, will egress out of that point. Many companies are now using things like distributed networks or decentralized networks, where the traffic can egress from multiple points, and if one specific node or firewall or egress point shuts down or has issues, then the traffic can redirect through a different point. And so decentralized networks are really great for availability and for uptime and redundancy and all the things that network engineers really work hard to keep going, because when the network is down, then usually work just stops in this case. So decentralized networks are great. For security, however, they are very difficult because you can't see all the traffic that's egressing because they're egressing out of different points at the network. And so you have to put multiple appliances or security devices at each one of those egress points, and that could be expensive and it could be complicated. So talking to your network engineers and understanding how your network is architectured, whether it's a traditional single centralized node or a decentralized network. It's also important to understand, like, if it's a flat network. Flat networks mean that you can route from and have visibility on any device that is on that network. You can ping it, so to speak. Whereas you can have several VLANs that don't allow routing, where they're segmented. So very commonly, you want to segment or isolate devices, servers, high-value targets in a network or virtual network, VLAN, that cannot be routed to from just anywhere. And you'll have things called ACLs, access control lists, where you'll have authenticated either machines or users or some other method in order for that traffic to then traverse into the segmented VLAN to talk to those high-value targets. So understanding how that is architectured, very important. If you are not in the network space, you should be talking to your network team and understanding how the architecture is so that you can help monitor and secure it.
Great introduction to the conversation. And I like how you brought up at the very top of that, a lot of the OGs in the InfoSec space all came from the network team. They came from network security because initially the network architecture was the security model. It was essentially, we're going to build, and it's used derisively today, but at the time it was at least a decent strategy. We're going to build this moat and castle strategy where we're going to have the moat be this protective layer. Nothing gets in except when we lower the drawbridge to let trusted things inside. And then we're going to close the drawbridge and it's going to be secure. And we're going to be very conscientious about that. Well, of course, we all remember the parable of the Trojan horse, literally the first Trojan horse, and how that got inside the moat and castle and was able to cause damage from the inside. And so that, of course, is the challenge with the model that we work to address through things you talked about, like segmentation and other concepts we'll talk about as we go along. And so I think even for those of us who have kind of come to this later or come through different means, like myself, I'll raise my hand. I definitely did not come from a networking background. And to me, in general, I try to articulate architectures and advocate for architectures that minimize the importance of the network, but networking still matters. You still need to understand networking concepts to be a good security defender. And again, most organizations aren't to that point of minimizing or nearly eliminating the concept of an internal, like, corporate network. We're not there yet. And so although that's a noble goal to kind of get to these really decentralized networks, the zero trust model, all of that, we need to recognize that this is still what we're charged with protecting today. And so having an understanding that is valuable. I recall when I went through my certified ethical hacker training, I had to learn how to do subnet masking. I had never done that before, like with CIDR notation. I had seen it and I didn't know what it meant. And is it something I'm going to use every day? Of course not. But having a conceptual understanding of it, I think, is valuable. And understanding network in general helps you understand, like, how attacks flow and may be structured as well. So there's still a ton of value to this. I see it as maybe a discipline that will decrease in value over time as we move to these kind of next generation architectures. But it doesn't change the fact that we have environments we need to protect today. And so having that solid understanding, even if it's not your direct responsibility, will make you better at everything you do as an InfoSec defender.
As you were talking, Adam, a concept just came to me that I had thought about previously, and I want to talk about it right now, because I think one of the most important things that's overlooked in network security, as with all security in general, is asset management. So understanding architecture, but then also understanding what you have on the network, where to find it, is extremely important, because if you don't know what you have, you can't protect it. And so asset management is something that can start out with maybe just a spreadsheet, but there are dedicated network asset management tools. And when I say asset management, it means I have server A and it's assigned this IP address. I have server B and it's assigned this IP address, or this subnet is allocated to this office. So if I look at that subnet and I see an IP address come up, I know exactly that's the Salt Lake City office or that's the San Francisco office. So you know, you're organized and you have things assigned. There's a concept called DHCP, which is where IP addresses are automatically allocated via a DHCP server. That is generally not how you want things done for your major assets or servers. Servers should be assigned a static IP address. The network team should be managing that. And then you should understand your different address spaces that you have. So private address spaces are allocated for internal use. It's called RFC 1918. And those address spaces are the 10.0.0.0/8. And then 172.16.0.0/12, and then the 192.168.0.0/16. Many people are familiar with the 192.168.0.0 because that's what most of our home routers are. Some of them use the 172. The majority of enterprises will use the 10.0.0.0/8, and it's a massive address space. And that's where you can assign different subnets to different offices, to different VLANs, to different things, so that you could look at an IP address and know exactly where that is or what network it's on. So Asset management, very, very important. If your network team doesn't have one going, I would highly recommend that they start organizing and doing that, because you're going to be looking at network traffic. You're going to find an IP address and you're going to ask, what asset is this? How do I know what is being compromised? And if you don't have a way to do a reverse DNS lookup or have a place to look at, which is written down, then it's going to be very tough.
That's hard enough to do on your home network. I was looking through my network devices earlier this morning, actually, and I saw some devices on there. I'm like, what is that? Because even a lot of like the Internet of Things today that you may have in your environment, they're really bad at self-identifying themselves, like coming up with a decent host name, which is beyond me why that's so difficult. But apparently that just tells you how poorly designed a lot of those are, that they don't have reasonable host names. And if you think that's difficult, imagine at enterprise scale. So it's important to really bake this into your practice and understanding what you have and where it is and all of that. That's a really great call out, Andy.
We're going to talk about firewalls. And even though we're in the age of zero trust, firewalls are still a huge component of network security at many, many organizations. So they can be hardware firewalls, like commonly Cisco, Palo Alto, Checkpoint, or they can be software-based, like the firewall that's built into Windows or Macs or Linux. But the idea of a firewall is to just control incoming network requests and allow or deny them based on rules. One of the biggest security issues is opening up ports. When you open up a port, it allows traffic that originates from outside of your network to communicate within your network. As a general rule, you should deny all and never open ports other than 443 and port 22 for SSL, TLS, and SSH traffic. Now, you might get these requests from application owners or program managers who are looking at different applications, say, hey, we have this new business enterprise application, but it needs, some random port open for communication. Again, those should be highly scrutinized and put through a security review and a business case, because anytime you're opening up a specific port, it causes a hole in your security, essentially, because traffic from the outside will be able to just come right in. So that's something that I would talk to the network engineers about. When I went and talked with my previous org and I talked with the security engineer there, the reassuring thing was we never open ports on our firewall, ever. So make sure you get a review of that, talk to your engineers, get a list out of if there are any ports, if there are, why are they open, what application is it for, so on and so forth. The other thing that I will mention about firewalls, and really just in general, is anytime you have physical assets, that requires physical security. So we did have a whole episode on physical security, but just as a brief review, anything that you have, especially firewalls that are the gateway to your internal network, you should have those in a secure location if you're hosting it on site, or if you're doing like a colo or a co-location of your hardware, you should have badges, retinal scans, man traps where it only allows a single person in and has let out before another person comes in, guards, access lists to get on. I mean, those are all things that you need to think about, because if someone can physically access your firewalls, then they don't need to do anything. They can just plug in and get access to them. So physical security, very important anytime you're hosting any type of network equipment.
Great call out there. I think of one of my first IT jobs. I sat probably within 15 feet of the entrance to the data center. And when I think of the level of physical security we had, it was not great. It was single key card, walk on in. And that's where all the stuff was. And I hope that's been hardened today, or at least moved to some sort of colo or more secure location, because it just sat in the office. And it was that easy to access. I mean, my key didn't open it, but a lot of people keys did. And I bet it would have been hard to tailgate in behind them. So, and that's a great point. Literally plug in and then you can reconfigure it. And now you've set your up persistent access from offline. Or offsite, I should say. And that's very scary. And then, the other thing to think about is if you're running the Gatekeeper firewall software, don't click the Pi symbol in the lower corner of the screen too.
Nice net reference there. For those of you who have seen those movies, or that movie, I should say. So after you have a firewall, you want to look at intrusion detection systems and intrusion prevention systems, commonly known as IDS or IPS. Some of these tools are built into firewalls, like Palo Alto, Cisco. They sometimes have an IDS or IPS system built in. Some of them you have to get a separate appliance for. There are IDS and IPS vendors that will have a security appliance that can sit on your network and then kind of look at things. An IDS is passive, and it will just look at traffic and detect malicious traffic and notify you. An IPS is active, where it will detect and then go ahead and block malicious activity. Whether it's a specific machine or an IP address, it'll say, I'm just going to block this from communicating on the network. Anytime you're using these security tools, visibility is important, which is why we talked about architecture. So if you have that distributed or decentralized model, you may have to have IPS and IDS systems sitting on each one of your egress nodes in order to see traffic that is coming in and coming out. So keep that in mind. You may not have a lot of say in how the network is architectured, but when you're looking at these tools, cost of how many appliances you have will depend on how it's architectured. So you want to have an understanding of that. An NDR, a network detection and response, is kind of that new generation of IDS, IPS. So you may hear that term. IDS and IPS have been around for a long time. NDR, which is network detection and response, is kind of like that XDR term that we use today for endpoint, where it looks at algorithms and machine learning and gets a baseline. So it does require to sit on your network for a period of time, usually a few weeks, and it gets a baseline. And then it'll look at different trends and use that machine learning and algorithms in order to detect visibility. Now, IDS and IPS, they were more like static, like if you had a list of malicious IP addresses or something like that, right? Whereas now the NDRs are looking at trends and algorithms. So you probably won't find straight IDS and IPS systems anymore unless they're built into the firewalls. NDRs are really, really nice. There are a bunch of different vendors out there that have really good NDR systems. Some of them are more network-based. Some of them are more endpoint-based. So take a look. Gartner has a great list if you're a Gartner partner or a customer of Gartner, or just ask around. There's tons. Do a search, and you'll find a bunch of different vendors who are in this space.
I think the comparison to endpoint's really apt, because before you moved on to the NDR subject, I was going to jump in and say, one of the things I learned when I went through this certified ethical hacker program was basically how easy it was to avoid detection by IDS or IPS systems. We would talk about doing certain things. We'd basically say, okay, if you do it this way, you're probably not going to trigger IDS. And so for the most part, it's a good comparison to endpoint. To use an analogy, IDS, IPS is kind of like signature-based detection. Like you got to have it to catch the really obvious stuff. But today, any remotely sophisticated attacker is going to be aware of that existence and is going to attempt to fly under the radar and prevent detection with that. And for the most part, unless you're doing really obnoxiously noisy things, you can probably avoid being detected by those systems. So the takeaway from that was like, don't do anything just stupidly obvious, like spraying every system with a port scan or something like that. You will, draw attention to yourself, but you could go do some reconnaissance first using not noisy methods, determine what a system is, run very light touch things to get like version numbers, and then go look for a specific exploit and then hit that with Metasploit. And long story short, it's a need to have, just like you still need signature-based detection for email and endpoint. But again, that's not catching the sophisticated stuff today. And I think NDR is where you may catch that. Although the risk inherent with anything that does baselining, if you already have someone with a persistent threat in your world and you build them into your baseline, well, then you're not going to detect them. So there is risk inherent with that as well. But just to kind of give that a comparison again for people who didn't come from a network background and may come from endpoint, that's something you can relate to and you go, oh, okay, I get it. It's kind of like next gen AV versus, previous gens of AV. It's that same kind of thing where, it's going to catch the obvious stuff.
Mm-hmm. Network access control, or NAC, is also a concept that most defenders should have an idea of. And what NAC is basically a protection against, like, when you're at your company, if I sign into the Wi-Fi, that's usually credential-based or TLS authenticated or something, right? Usually your company has a guest network, but your physical ports may not be protected. Now, some environments, like a lab or something like that, you may have a port mapped to a specific VLAN. Like if you have a lab that is very sensitive and you want to make sure the network traffic and everything that's plugged in there can only communicate with things, you can map a port to a specific VLAN. But most of your office stuff is probably on whatever network that usually communicates with everything else, file servers and all that. And so most companies don't have NAC that I've seen or worked at, which means that for physical LAN ports, if you plug in any computer into the LAN, it will just get the internet and be on the network. So a NAC will require some sort of authentication, whether it be a MAC address or a username and password or a certificate of some sort, in order to get onto the network, specifically for physical networks. Now, they apply to Wi-Fi as well, but most of the time Wi-Fi is authenticated at this point. We're really talking about like physical ports that you're plugging into. So NAC can be important because it'll prevent anyone from just plugging in a machine to a port and then getting onto your internal network. That assumes that they probably got past your physical security if you didn't have physical security. So just understand, it's a important control that can be a defense against specific use cases.
My previous employer before Microsoft had NAC pretty much, I think, fully in production, both on physical Ethernet ports as well as actually on the Wi-Fi. And at the time they were using Mobile Iron and had it synchronized with, I believe it was Cisco ICE they were using for the solution, but you had to pass a compliance check in Mobile Iron and then report that status to ICE before you got that full Wi-Fi access. And then I think most of the Ethernet ports were done by MAC address. I think, I'm not sure. And then here's where the problem comes in. That's good from keeping somebody just walking in the door with, like, I brought my computer from home, plug it in. But getting an exception wasn't hard. So they had this whole process, and this is where exceptions management matters as well, as you need to have a plan in place for how do we handle exceptions and what are the requirements to do that. I was basically able to say, hey, we bought this iMac to do video editing for our IT lunch and learns. Here's the MAC address. Can you add it? And they go, okay, done. I mean, like, that was all the more questioning there was. Now, was that Mac a threat to that network? Heck no. I mean, I kept it patched and I wasn't doing anything on it other than exactly what I said. And, Macs have a pretty good baseline security posture, so it was fine. But again, it was one of those, they'd done all the work to stand this up in production on Wi-Fi, on Ethernet. And at the end of the day, the exception process was the whole, because I could just say, hey, I want an exception. And they're like, oh, you're in IT? Okay, what's the MAC address? Done. And IT people do some very stupid stuff. They're very guilty of do as I say, not as I do, right? Especially InfoSec people. And we don't always hold ourselves to the same standard as our users, unfortunately. And I think we've done other shows on that. But point stands of, even if you get this deployed, which again, a place I worked at 7 years ago did, make sure you thought through all the possible weakest links.
Good call out there, Adam. The final thing that we'll just touch on is administrative security. So anytime you have appliances, firewalls, you need to manage access to them. And how are you defining access to these? A lot of times, because network appliances are on-premise, they're usually integrated with on-premise identity, specifically Active Directory. And so you probably have a security group within AD that grants access to the network appliances. Maybe there's LDAP or secure LDAP, however it's configured, that the appliance can read Active Directory or is authorized with those security groups, which means that you need to manage how the security groups are then changed. So who has access to the security groups? Can I just add myself to them? Does your tier 1 help desk analyst have access to just add themselves to the network admin security group? So those are things to think about, as well as, if it's not native, then it's probably, or if it's not using Active Directory, then you might just be using local users that are native to the firewall. That's one way to do it as well. But then you have to manage multiple credentials that are not within your centralized identity system. Mm-hmm. There's usually also like a master administrator password to these appliances. So you want to make sure that those are stored securely as well. Preferably not in a cloud password vault would be my recommendation. If it's an on-premise thing, I would try to store it in an on-premise type vault, maybe even on a physical piece of paper that's stored in like a physical vault.
Well, speaking of weakest links, you kind of went into another one there where just managing administrative access is very, very important too. So these are things, even though they're last, they're certainly not least in terms of importance. And I think any of our listeners, they understand this. So these are great questions for you to ask as a security defender of your network team, just making sure that everything's buttoned up there.
And then just some food for thought, because this is the world of zero trust. So possibly in the future, as you're looking at projects, if you're a security architect, one of the things that you could bring up to your network team is, why do we have firewalls and why do we have an internal network? Can we just get rid of it? Many years ago, Microsoft got rid of our intranet at our offices, our remote offices, where it is just straight out to the internet. There is no intranet, because a lot of things that we access are online, just SharePoint, OneDrive. And if you need to, you just VPN to a specific resource or gate it behind app proxy. And when you do that, then you can kind of get rid of some of these controls that are harder to manage for on-premise things. One of the benefits, if you are within the Microsoft ecosystem, and if you're using Defender for Endpoint, it has a really nice detection method where if it detects a malicious endpoint on the network that your protected asset that you're using is sitting on, it can then block communication from that malicious endpoint to your computer. It doesn't prevent that device from communicating with other things on the network, or just, remove that, but it does prevent it from communicating with your protected asset. So that's kind of a nice thing, because you don't even need to be an admin or do anything. Defender for Endpoint is just protecting your device from malicious things that are sitting on the same network. So some food for thought, future projects, possibly getting rid of firewalls, moving to a zero trust, just straight out to the internet kind of model.
Absolutely. I think, again, we're recognizing that is the North Star for almost every organization, is to minimize their CorpNet and make it smaller, shrink it down. Obviously, more and more things are moving to PaaS and SaaS models, so there's just fewer apps that need to run on a quote unquote like internal network. And then you really don't need endpoint devices on the internal network at all, especially if you've done the work to move your device identity away from on-premises Active Directory, which really is a lot of reason any organization at all needs their like user devices still on CorpNet. And so we've done plenty of shows on that. We did 2 with Shannon Fritz about it. You should go check them out. They were some of the most listened to of all. So the point you kind of land on is all of this is interconnected, like everything. And there's all these different efforts you can undertake to kind of move things forward. But for a lot of orgs, they still have work to do here. And so that's why we're talking about it. But absolutely, be thinking about that future state too of how do you minimize this? Everyone's goal should be to have as few of devices on a quote unquote like internal corporate network as possible. It shouldn't be a huge number. And it is kind of crazy, really, when you start to live in that world of I have full normal access to do all of my day-to-day work with just an internet connection. And I use VPN sparingly, maybe once every 2 weeks, to access like very specific sites that haven't been exposed through app proxy, that are still internal. And when I'm talking about like, when do I need to do that? It's like some ancient like SQL Server reporting service instance, or it's some ancient SailPoint instance or something. Like there's very rare circumstances. Otherwise, if I have an internet connection, I can do my job. And whether I'm in the office or out of the office, the user experience is exactly the same. I don't do anything different. There's really no concept. Like that's a powerful moment when you get there. So do think about that as well as you're doing all of this work of how, not that we're trying to put anybody out of a job by any means, but it's clearly a desirable future state.
Well, hopefully you enjoyed our network security episode. That is our show for this week. Thanks for listening and watching as always. Our contact information will be in the show notes if you have any questions or comments or topics that you want us to talk about in the future. Thanks, and we'll talk to you guys next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJ Brewer. See you at our next episode.